Hi, today we are gonna design a shrine hidden within a giant stone pillar. Believe it or not, this model is entirely procedural, meaning that I haven't sculpted or modeled anything. It's all made with geometry nodes, that is to say, mathematical formulas. The model is made with 3 node groups. First, the column, basically a cylinder to which I applied a noise texture. Second, the stairs. This node group is a little bit more tricky because it's designed to wrap around anything, so it's extremely flexible. Third node group, the temple itself. Finally, this model is meant to guide us in the construction of a real diorama. But now, let's start. To create the column, we can just keep the starting cube and go straight to geometry nodes. Let's create a new node. Let's call it noise, because we'll be applying a noise texture. I can replace the starting cube with a cone. I prefer the cone rather than the cylinder because it's more flexible. Let's make 20. Since you can control the top and bottom radius, which we'll be using right now. Let's make 7, this one 9, and the depth 50. So, we need to increase the surface with a subdivide surface. Okay, 4 may work. And finally, we need to offset the position with a set position node. Now, we can apply the noise, but as you can see, the object just flies away. So we need a couple of vector math nodes to control the noise texture. So the first will be a subtract. Since the noise goes from 0 to 1, if we subtract 0.5, the objects will stay in place because it will go from minus 0.1, minus 0.5 to plus 0.5. The second is a multiply, and we multiply by the normal because we want the offset to go outwards or inwards with regard with the surface. The third one is a scale. Since we want to control the amount directly from the group input. We might also want to control the noise, and in order to avoid confusion, we can just rename the second one to noise. So now if I change the amount of noise, as you can see, you get a rougher and rougher surface. However, now the roughness it's also being applied to the top and bottom. So in order to avoid that, we can just separate X, Y, Z and combine. And we exclude the Z, so now the top and bottom are flat. So let's also add a shade smooth. And that's it. Now we have our column, which can be basically controlled directly from here. So the first piece is okay. Let's move on. Nodes. New node, let's call it stairs. I'll be using a curve spiral as starting geometry. So let's add a curve spiral and let's use the starting radius 9 and radius 7, just like in our cylinder. Let's zoom in. There's one issue we have to solve, however, and let's make the difference bigger just to visualize it. So, as you can see, the length of each segment is variable. So here is very short, here is very long, but since I'll be instancing the steps on each vertex, they have to be equal. So I have to resample this curve. And let's make it equal to the resolution. Okay. So right now the problem is solved. So the distance is the same for each segment. Now let's instance the steps. Instance on points. And let's choose quadrilateral. Let's make 5 centimeters and fill the curve. Now, as you can see, there are gaps and they're not aligned. So let's first align them with align Euler to vector. And we use as vector the tangent. And now, as you can see, they're properly aligned to the center. However, the distance between them is not the distance we need, so let's make some room. So we have to use the curve length and divide by the width of the steps. So let's use curve length and a math node, so we can plug the width here and Shift A, search math node. If I divide the length by the resolution and plug it in the height, I get what I want. So now, as you can see, there are no more gaps. We still have a problem, which is that, as you can see, the outer edge is not in contact with the adjacent step. So we have to work here on the scale. I used a map range. Actually, I need float. And as value, I choose an index. Okay, and let's make it 1.4. That works. So now, as you can see, basically all the steps are in place, but the stairs is still bidimensional. So we have to extrude the shape. Let's first realize the instances and then search extrude mesh. If I work with the offset scale, as you can see, it's offset by a constant value. So I have to use an index here too. If I choose the index, however, I don't have much control over the amount, so I have to use some math nodes. Let's first choose an add. This way I can control the offset, and Shift D, divide, and I divide by a value that I can decide. So it's better to use an extra node. Shift D, multiply, and let's try with 10, okay, maybe 20. Now, as you can see, I have the possibility to choose the height. Let's rename this value with height. And let's plug this value here too in the group input, and let's call it offset. So, as you can see, I can decide the offset, the height, the resolution, and the width, as well as all the other parameters of the spirals, which maybe I can just plug here for convenience. The height here, 0. Now our stairs are ready to be used. Okay, now let's apply the stairs to the column. So let's change the parameters of our stairs. Okay, as you can see, they wrap around our column. Actually, the column is way too rough. Let's change a little bit these parameters, and let's change also the level of details because it's too low. Okay, here we are. Now it's time to make the temple. Geometry nodes, inner temple. Our temple is going to be circular because it has to fit inside the column. So I'll be using a curve circle as starting geometry. And I'll be instancing some columns around this circle. So search instance on points. Okay. However, there are too many columns, so I better resample this curve. Okay, and let's make it 8, which is close to the radius of our column, but we we can change it later since it's procedural. We don't have to worry about this. So let's make Shift D, and we need, of course, to have a base, and the base have to be extruded. But we have the possibility to improve the design by creating some interesting features. So let's first join these geometries and now extrude the mesh. In order to have it visualized, let's add another join geometry. And now, as you can see, we have our base. This curve has to be filled. And the extrusion has to be controlled. So let's use a math node. Divide, and we divide by an amount we decide. Okay, we need to reset the position, so set position here and on the Z. Okay, so that's our base. Maybe it's too much. I can reduce the amount like that. That works. And now let's create a hole in it with another curved circle. So another join geometry. So we just plug here, this here, fill curve here, and then an extrude mesh. Okay, this is our basic design. Okay, now we have all the objects we need. Actually, there are two more objects that are actually a very simple elaboration of the previous node groups. Actually, the stalagmite is exactly the same node of the column with different parameters, while the door frame is just a simple elaboration of the temple. Let's apply some texture. I've exposed the material here since it's far easier and actually the best way to apply materials to geometry node objects. So let's select the material. Okay, bricks for the temple, then rock for the stalagmite and for the stairs as well. Rock for this, and finally bricks for that. Now I bring in our special guest, which is the only non-procedural model in this scene, which is a spider, just to spice up things. And now let's move on to our final scene.